Greetings and welcome, friends. Mr. Wada here. We're talking about section 8.3, graphing quadratic equations, these parabolas. When I've got a B term is basically the big change that we're adding today. What happens when I add a middle term to the graph? And sadly, it is going to screw up so much stuff for us. Our wonderful system of graphing using my quote-unquote slopes falls apart when it's in this form. But don't worry, mathematicians have not left us high and dry. We will still have a means of doing this while avoiding making too much of a table of values. So here's some interesting facts about this graph. The graph opens up when A is positive. All right, we knew that, right? So A still is going to affect, now it just looks like a 2. I don't know. It's still going to affect the steepness of our parabola, but this B actually affects the steepness a little bit as well. But when A is positive, it will open up. When A is negative, the graph will open down. Another interesting thing is that the plus C will not determine the vertex anymore, but it does determine the Y-intercept. Okay, so the Y-intercept will be here, whereas in our previous examples, when BX did not exist, the vertex and the Y-intercept were the same, right? It looks something like that. So the plus C is your Y-intercept, not unlike in Y equals MX plus B, where this time, right, that was always our Y-intercept. So the constant term, you could say, in general, for any equation, parabola or not, will always represent your Y-intercept, okay? And then it says this. This is like key fact right here for our vertex. Right here. Our vertex. Austin, we're not talking about that right now, man. No. Don't worry, Austin. Don't worry about it. We're talking about this right now. So the x-coordinate of the vertex, they've given us a little equation which is negative b over 2a, is how I can find the x-coordinate of this vertex. All right? So that's where I can find the high point or the low point of our parabola. And then the axis of symmetry will be the equation of the line x equals negative b over 2a, where, right, x, this mirroring line just is going to be this equation, right? X equals some number is always going to be the equation of a vertical line, and that number will be the x-coordinate of the vertex, is what's going on there. All right, so lots of stuff going on. We're going to slowly implement this over time. So let's first start with example 1. Here we go. Example uno. Find A, the axis of symmetry, and B, the vertex of the graph for our equation over here. So the first thing I'm going to ask us to do, could you tell me what A, B, and C are for this graph? So, this is why this is so important. A is just the 2. A is just the 2. Okay, and I actually mandate that you write A equals 2, because I've also had, because that error, sometimes people are like, oh, 2x squared is A, or 2x is A. Sometimes students will just try to like write A and then point, and I don't know, are they pointing to the entire thing? Are they pointing to just the 2? Pointing is not a great thing to describe things mathematically most of the time. We use equal signs, so A equals 2. The B is going to equal 8, and if this was a minus sign, then it would have equaled negative 8, okay? So the B is the coefficient of the x term, but it does not include the x, it's just the number. And the C is going to be the constant, which is the negative 1, so including that sign, the negative 1. So they want us to find the axis of symmetry. In order to do that, I'm going to need my little formula, negative b over 2a. And I'm actually, you know what? I'm going to call this preemptively, I'm going to call this h, where we will call the vertex, all right, our vertex we will refer to as h comma k, all right? And finding k is going to be tricky, but h, they've given us a formula for. Someday you'll see where that little formula came from, and it's kind of interesting. It's related to the quadratic formula, but you guys also don't yet know what that is. So that's fine. Don't worry. Here we go. So let's first figure out what is this H component, the X coordinate of the vertex. So I'm going to plug in B and A in this little formula and see what I get. So I'm going to get H equals the opposite of B, being 8, over 2 times A, which is 2. All right? So H equals negative 8 over, what's 2 times 2? 4, yeah, not a trick question. And negative 8 divided by 4 is going to be negative 2. So H equals negative 2. And now with that, I can answer the question, what is the axis of symmetry? And the axis of symmetry is going to be the equation x equals that number. All right, is the axis of symmetry. X equals negative 2 is the equation of the vertical line. We'll actually show this graph in a moment, right? Is the equation of this vertical line that the graph is mirrored over, right? So that's what I just found. That's what is referred to as the axis of symmetry. But now they want to figure out what is the vertex. And, well, I know the x coordinate of the vertex. I know this is negative 2. And now the question is, how could I find the y-coordinate of the vertex? And I'm going to show you another little formula that they didn't write. The y-coordinate of the vertex is just going to be f of h. All right? Whatever I get when I plug my x-coordinate into the function, right? Here, here, and here. So I'm going to plug in h is what I do. I also could have referred to this as f of negative b over 2a, but that's a little bit weirder, but that is the case. So let's figure out what k is. Unfortunately, my friends in real life and I, we just practiced a very similar skill to this in our warm-up. So k is going to equal whatever f of h is. So let's figure that out. So f of negative 2 is going to equal 2 times negative 2 all squared plus 8 times negative 2 minus 1. And now I'm just simply going to PEMDAS this, right? Parentheses, exponents, multiply, divide, add, subtract, where multiplication, division take place in priority from left to right, as well as addition and subtraction. So f of negative 2, the first operation that's going to take place here, I'm going to do this exponentiation. All right, so that's the first thing I'm going to do. I don't do the multiply before I do the exponent. And over here, because this is separated by a plus sign and a minus sign, I can do this multiplication. Question? What I'm doing is I'm plugging in negative 2 for all of the x's up here. Is where that's coming from. So let's see. So 2 times negative 2 all squared. Ooh. Question, is negative 2 all squared, is that positive 4 or negative 4? Well, squaring something means to multiply it by itself. What's negative 2 times negative 2? That'll be positive, okay? So when it's inside parentheses like that, it will end up being positive. Super easy to get that wrong. So 2 times 4 plus, or wait a minute, maybe I should leave that as a minus, because positive 8 times negative 2 will be negative 16 minus 1. Right, now I'm just PEMDASing. I'm going to go slow with this first PEMDAS for our sake. The next thing I would do is the multiply. So 2 times 4 is 8, minus 16 minus 1. And I'm going to do this leftmost subtraction first, right? Because subtraction and addition is from left to right. So 8 minus 16 is negative 8. Minus 1 is going to be negative 9. So I just found that f of negative 2 is negative 9. That's basically what I did, was I plugged in negative 2 in the equation here and found out what the output was. And I'm telling you that that will also be the y-coordinate of our vertex. So h is negative 2, k is negative 9. And that means our vertex is -2, -9. Now, I want to graph this in Desmos for us and just verify this. Because doing a whole bunch of algebra, like sometimes visualizing what's actually going on will be more helpful. So the vertex is going to be... Actually, question, can any of you tell me, based off of the little facts I gave you up here, this little list of facts, can any of you tell me what direction does this parabola open? Does it open up or down? This particular problem, using some of the facts that you see based on that. Let's see. How do I tell which way it opens? Wait, where does it say? It opens up when and opens down when. Which is it? When what is greater than 0? So when, and in our case, what is a equal to? Well, my equal sign got written over, sorry. So it's a +2, so it opens up. Yep. Right, so that's what we anticipate for this graph. So let's graph this. So 2x squared plus 8x minus 1. Here's a little graph that I made earlier. Let's override this. Actually, no, I guess I could do it this way. 2x squared plus 8x and then minus 1 for c. And so here's the graph. And we anticipated that the equation x equals -2 would be our axis of symmetry. Does that look like the axis of symmetry for this parabola? Yeah, that vertical line, it definitely is. And we anticipated that the point -2, -9 was the vertex. And does that point look like the vertex? Definitely does. Way cool, way cool. All right, and so we are actually expecting that our vertex... Oh, they wouldn't let me get away with that, would they? I wonder, can I change this to f of x? I can. Ooh, check this out. Watch this. What if instead of this, what if instead of -2, what if I wrote negative b, over 2a? And now even if I change a, that's locating the x coordinate of my vertex correctly. And then the y coordinate I said was f of, right, f of whatever the x coordinate would be. Let's see if this will work. -b over 2a. Watch this. Did I just make a dynamically generating vertex? No way. I did it, guys. So wherever I move this, the vertex, the orange point, is in fact happening at the x-coordinate is -b over 2a, and the y-coordinate is whatever I get when I plug that x-coordinate into the function. And the axis of symmetry should be x equals -b over 2a as well. And let's see, if I change this around, yeah, look at the vertex and the axis of symmetry track with it. Awesome sauce. Look at that. That's amazing. Vertical shifts still work the same way. Amazing. Upside down, right side up. Yeah, so there's some visual buy-in. I just made it into a line by making a equal to 0. That makes sense, though. So there's some visual confirmation for us there. All right, let's see. Let's look at example 2. Giraffe. We're gonna graph it. Can you believe it? Graphing quadratics, my dream. All right, I was just like imagining if I like Disney sang about math. That'd be pretty cool if I could do that all the time. All right, so here we go. So you guys have your graph. We've got this equation. Let's see if I need you guys to help me out. I'm gonna use our cards here. Let's remove our absent student. All right, first question. All right, Kayla. All right, don't worry. Nothing crazy, nothing intense here. What do you think A is equal to here? I agree. A is equal to 3. All right, let's see. How about Austin? What do you think B is equal to? Oh, it's just the -6. It's just going to be the number. But I would refer to this as the B term. But if I just want the B, that's what I'm looking for. Let's see. Micaiah, what do you think C is going to be? Yeah, just the 5. Perfect. All right, so what I'm going to do if I want to graph this, I'm going to want to find a few things. Let's find the vertex first. All right, so let's first find the vertex. And in order to do that, I'm going to use our formula for H, which is the -b, over 2a formula. And then I'm going to find K by doing F, because this is function F, of H. I'm just going to plug whatever I get in. So those are the two things I'll do to find the vertex, and then we'll be able to graph the vertex on my graph over here. This is going to be great. This is going to be good stuff, friends. I love it. All right, so let's find H. So H is equal to, all right, let's see if you can help me here, Brandon. H equals -b over 2a. So negative of b is going to be the opposite of what now? Negative b, what's b? No, the -6 here. So the opposite of -6 over 2 times, and what was a? 3. All right, and now notice I plugged this in parentheses just to be careful with this double negative here. Brandon, what is the opposite of -6? Yeah, +6. And 2 times 3 is Austin? Yeah, Austin. 2 times 3? Yeah, 6, and 6 divided by 6. Micaiah, what do you think is that? Yeah, just plain old 1. So I'm anticipating that H equals 1 for my vertex. So I know somewhere on that line is going to be my vertex. I now have got to figure out what is K. All right, and in order to do that, I'm going to figure out what is F of 1. All right, and that 1 literally comes from taking this and plugging it into the function. And what is our function? I've got to scroll up a little bit. 3x squared minus 6x plus 5. So let's write that out. So equals, let's see, Kayla, if you can help me plug this in. So 3 times, instead of x, what am I plugging in? What's being plugged in for x? Right, I'm plugging in the 1. So 3 times, instead of x, is 1 squared. Minus 6 times, what am I plugging in, Kayla? Yeah, 1, and then plus 5. And now we're just going to PEMDAS this. All right, so let's do 1 squared is 1. And -6 times 1 is -6. And I'm going to ask you guys to write this out, because this is honestly probably the most likely place we'll make a mistake, is just in some simple PEMDAS error. Let's see, 3 times 1 is 3, minus 6 plus 5, and 3 minus 6 is -3. And feel free to like reach for a calculator for like some of the squares or the multiplying. That's fine. I just want to make sure you're like doing it in the right order. Don't try to plug this all into your calculator. All right, let's try to at least write down what's happening. -3 plus 5 is +2. So f of 1 is 2, right? What I got when I plugged in 1. Here, I'll even show that we plugged in 1 here and here. Look at that. Ooh, I love these colors, guys. Colors make me so very happy. All right, I get f of 1 equals 2. So what is my vertex? It's going to be an x comma y. What's the vertex? 1 comma 2, right? The h comma k is my vertex. So let's plot my vertex over 1 and up 2 on my graph. Fortunately, I planned my grid accordingly, so it'll fit in this space provided. All right, the next thing I should find is the y-intercept. Okay, the y-intercept, as some say. So the y-intercept is actually, yep, sorry. So the y-intercept, looking at our little information table about graphing these, where do I find the y-intercept? Does anyone remember? Look back on your previous page. Nope. Slope-intercept form is for lines. The little picture of the parabola information we had, what did it say? Okay, yeah, actually, tell me that. Does anyone know if this opens up or down? So is our A bigger or less than 0? What is A? A is positive 3, so I'm expecting this to open up. And the y-intercept is C, so what's the y-intercept? And what is C? 5. C is equal to 5. C is the constant here. So I'm expecting 0, or the y-intercept is 5, but I'm also going to just write that as the point 0, 5. I feel like that can help us out. So here's 0, 5 right here. Now, another piece of information I know is the axis of symmetry always is going to pass through our vertex. All right, so I could imagine this as my axis of symmetry. So once I know this 5 as the y-intercept, I know there's got to be another point that could be mirrored. Let's have you guys draw, where do you think that another point I could guess is based on the axis of symmetry, the purple line, and that 0, 5 point. So draw on your graph where you think that is. I'll walk around. Like it. No computation necessary. Great. So when I mirror this over the line, this is 1 unit away. So 1 unit away on the other side. Free points. Awesome. Because I do not want to have to do a whole lot of table of values stuff. Right? No, thank you. Now, this is where it gets a little bit risky. All right? If you're familiar with the shapes of parabolas, could you arguably like kind of imagine what this looks like, right? Like could you kind of know it's going to look something like that, right? We know it's opening up, we know that's the vertex, we know it hits those points. We should technically get 5 points total. Right now I've got 1, 2, 3. So what I'm going to do is I'm going to plug in let's plug in this number 3 and figure out where does it land when x is 3. And then I could mirror that point over as well. So I am going to do one input here just for an extra point. So for extra point, I'll just call these extra. Because I just want to have a little bit more definition. Let's figure out what is f of 3, right? And I picked that because I was like, I know what it was equal to at 0. I know what it was equal to when x was 1. I know what it was equal to when x was 2, and I figured 3 would be easier to plug in than -1. You could have plugged in -1. You really could have plugged in anything. You could have even plugged in a half and figured out where it was, or 1.5. But 3, I think, is going to be an easy thing. So, so let's figure that out. F of 3 is going to be 3 times 3 all squared minus 6 times 3, and then what was it, plus 5? Did I have the right equation when I plug in 3? Yeah. 3x squared minus 6x plus 5. And this is where it's a little bit table of values, but we've at least been finding out most of the information of our graph somewhat intuitively. 3 squared is 9. 6 times 3 is 18. Plus 5. And I'm going to get 3 times 9 is 27. Right, so you could use a calculator on some of these calculations. That's fine. 27 minus 18 is 9 plus 5. I get 14. I almost said 15. 16, I mean, is what I would. Yeah, I guess there's multiple wrong ways I could have said it. So I get f of 3 equals 14. That means the point 3 comma 14 is on my graph. So let's plot 3, 14. Right, and you technically could graph this whole thing using a table of values, but we don't really want to do that. So over 3 and up to 14, here's another point. And how could I find a fifth point for quote-unquote free? Yeah, I can mirror this, right? Sure. So this is 2 away, so 2 away over here. There's going to be another point. Yeah, I'll scroll down. So yeah, so you can technically plug in any values of x and find a whole bunch of information if you want. But I find having to calculate and plug in numbers, that's a lot of work. So I'd rather try to get as many free points as I can, right? Getting the Y-intercept just by looking at the C term, super easy. Plugging in numbers into the function and then PEMDASing, ugh. No, thank you, right? I want to avoid that as much as I can. So here we go. So let me draw this parabola. This is going to be the last example we do today, and then we'll get you guys some practice. And I like to draw my parabolas downward facing because I'm just better at that for some reason. Just the way the curve of my hand goes. Right, so this is getting steeper and steeper, faster and faster. And so when we're graphing, sure, I can always do a table of values to get an idea of the graph and represent it. But more intuitive approaches are always going to be better. I'll scroll down in a second, but I'll just say bye to our internet friends.